Okay, so before we get started with the notes, there's a couple things that I need to talk about regarding end behavior. It was on the last test, and there was quite a few people that missed it. So I want to talk about end behavior and talk about graphs and stuff like that before we get started. So just to review, there's two types of end behavior that you have to memorize. You're going to have something that has an even exponent and a positive in front. If that happens, that guarantees your graph's going to point up and up for the end behavior. If you have a negative, then they just flip. So if you have negative x and this is even, that flips it so it points down, down. If you have an odd exponent, the left side points down and the right side points up, as long as there's a positive in front. Your negative, all it really does is flip the end behavior. So if you have a negative in front of an odd exponent, the left side points up and the right side points down. Now you don't have to memorize all four of these, you just have to memorize two of them, and then you have to know that the negative just flips the end behavior. Now the other thing that I want to talk about that a lot of people missed on the test was this guy right here. So I have a graph plotted and it has a 0 or a double root at 3. Now a lot of people thought on the test if I needed to change the end behavior and keep the same zeros, all I had to do was throw a negative in front. So I just want to show you what happens if you put a negative in front. If you put a negative in front, it does flip the end behavior, but now it doesn't have the same zeros anymore. So the way you keep the zeros the same and flip the end behavior is you have to add parentheses. So if I go back here and I put a set of parentheses here and back at the end, that should keep the 0 exactly where it was and just flip the graph over. A lot of people just threw that negative in front without the parentheses and they lost points. Now our end behavior is going to be written a certain way, so just to review that, this piece right here says x negative, so that right there means left. This right here says x positive, so that means right. Then when we talk about f of x, this is actually a y, so this is saying y is going positive, so that's up. And then this right here is y is going negative, so that would be down. So you're going to have to know that because they're going to give you some stuff. You're going to have to write the equation, and then they're going to have to adjust it to follow this end behavior. Now, one of the things I was trying to stress in the last set of notes, in 5C notes, is that every square root and every imaginary solution always has a plus or minus. So if they don't give it to you, it's your job to add that extra one in. So here's how you write an equation if they give you the answers. So you guys already know you just reverse the zeros and you put it in parentheses. So for example, if they give you x equals 4, when you write it as a factor in parentheses, it's going to be x minus 4. If they give you a fraction, so let's say x equals, I don't know, 2/3, the pattern still holds, except you have to do a bottoms up here. So this is a positive, so in here I would stick it as a negative. The top number goes in this spot, and then this bottom number, it kind of goes bottoms up in front of this x right here. So it's going to be, 3x minus 2. If they give you a square root, so let's say x equals square root of 2, that automatically means you're going to get x minus square root of 2 and x plus square root of 2. Remember, square roots always come in pairs, and that's the same thing with your complex. If I tell you that the answer is x equals negative 3i, that means that we're going to have a parentheses of x plus 3i and x minus 3i. So when they give you this answer, these are always plus and minus, and these are always plus and minus. So these right here always come in pairs. So I'll put right here plus or minus. Now, after you get all your parentheses set up, you're going to multiply. Anytime you do the square roots in complex answers, there's going to be some shortcuts that you can use. That's the one where you, let's say you have a plus b and a minus b. That's the one where you just multiply these two and these two together, and then you can continue from there. And then the final thing is you're going to have to adjust the signs for end behavior, and that's only if necessary. Okay, so let's start. So I'm going to start off by, let me make my pen just a little bit skinnier. I don't even know how to do that. Oh, well, I'll just use a fat pen, whatever. So I'm going to go ahead and start with the first one. It says the zeros are 4/3. Let me just see how I wrote this. Zeros, yeah. So it says the zeros are 4/3, 2 minus 4 plus I. As a matter of fact, let me just look at these examples really quick. Let's start. I'm actually going to do these notes backwards. So we're going to start from example 3. So you have to turn your page over. So starting with example 3, this one doesn't have anything fancy, so I should have probably put this as the first example. So they're saying x equals 3. So that means in our parentheses, it's going to be x minus 3. Now the thing you have to be aware of again is i's come in pairs. So that right there, that's going to be plus or minus. So that means over here, we're going to have x minus 2i, and then x plus 2i. And then when we multiply, you can multiply anything you want, but I highly recommend you do any shortcuts if possible. So we're going to start off by, let me scoot these down. And we're going to start off by multiplying these two together and then multiplying these two together. So this right here gives me x squared minus 4i squared. But we learned in the other set of notes, I squareds basically flip the sign. So this ends up just being x squared plus 4. And then what we're going to do, let me write that again, x squared plus 4. Then we're just going to bring down the other one, x minus 3, and then we're going to multiply that out. So x times x squared is x to the third. X times 4 is plus 4x. Negative 3 times x squared is negative 3x squared. And then negative 3 times 4 is negative 12. Now I'm just going to rewrite this real quick because it should be in order by the exponents. So x to the third minus 3x squared plus 4x minus 12. Now it looks like we're done, but not really, because we have to go back and make sure the end behavior is correct. So this one says as x approaches negative, so that's the left side. So I'll write that real quick, left. It's saying the left side right here is pointing up, and this one right here is saying the right side is pointing down. Now the one that we have right now, it's got a positive in front, so that means that, let's see, positive and odd means left side down, right side up. So these instructions up here are telling us to flip the end behavior. So that means that we have to put the whole thing in parentheses and then just put a minus in front, and then that's our answer. Okay, now let's do example 2. We'll just keep working backwards. Okay, this one's good because it's got the plus or minus. So let's see what we got here. X minus 8, x plus 8. Then we have the bigger parentheses, complex solution here. So we're going to have x minus 2 minus I square root 3, and then x minus 2 plus I square root 3. Okay, so you can see here we have a couple of shortcuts that we can do. So I'm going to do this guy here. Oh, I did the wrong one. Hang on a second. This guy here and this guy here. So this part right here is going to become x squared minus 64. Now in the second one, this is the one that we learned how to do in the last chapter where we put the brackets around the first two. And basically we're turning it into a shortcut. So we're going to multiply these two together. So that's going to give me x minus 2 squared. Let me multiply these two together. So this one's going to give me negative, what is that, 3i squared, which basically turns it to a plus 3. Then we can do the shortcut on this part, perfect square. So x squared minus 4x plus 4. And then we bring down the plus 3. So all of that stuff turns into x squared minus 4x plus 7. Then we have to multiply it times x minus 64, x squared minus 64. Now we multiply all of this out. So that right there is x to the fourth. That gives me negative 4x to the third. That gives me, let me see, x plus 7x squared. And then we do negative 64x squared. Let's see, yeah, negative 64x squared. Then we have, I'm going to have to use my calculator over here. So exit, go into the menu. So negative 64, let's clear all this out. Negative 64 times negative 4. That's 256x. That's going to be a positive. And then negative 64 times 7. Negative 64 times 7. Negative 448. Combine like terms. X to the fourth minus 4x to the third. Got the calculator, so let me just do that real quick. 7 minus 64. Oops. Probably 57. Yeah, negative 57. Plus 256 minus 448. Now, before we say that's the answer, we got to go double check. So this over here is left up, and this one is left up. Now, if you look at the highest exponent, this one right here already is up, up, so we don't have to make any changes, so that would be our final answer. Okay, now we're going back to example 1. So in example 1, we have the fraction. So anytime you have a fraction, and this right here, I'm going to put those instead because it looks like it's a negative 4/3, but it's not supposed to be. So the 4/3, here's how the 4/3 goes into the parentheses. It's a positive, so that makes it a negative. The top number goes here. The bottom number goes in front of your x. And this right here, don't forget this one, anytime you have an I, it comes in pairs, so that's going to be a plus and minus. So we're going to have x minus 2 minus 4i, x plus 2, no, not plus 2, that's a minus 2, and then plus 4i. Let me rewrite that part. I don't like that part, how I wrote that. So minus 4i, x minus 2, plus 4i. So the only shortcut we have here is this one. So we're going to put these in brackets. Multiply those two, so that's x minus 2 squared. Multiply these two, minus 16i squared, so we can easily fix that and turn to a plus 16. This right here turns into x squared minus 4x plus 4, plus that extra 16. So then we combine the 4 and the 16. X squared minus 4x plus 20. And now we can multiply that by 3x minus 4. So 3x times this one is 3x to the third. 3x times that one is minus 12x squared. 3x times that is plus 60x. Negative 4 times that is negative 4x squared. Negative 4 times negative 4 is plus 16x squared, or x, sorry. And then negative 4 times 20 is negative 80. Put all this together and we get 3x squared minus 16. Just kidding, that's an x to the third. Minus 16x squared plus 76x minus 80. Now you look at this problem, it's got the positive and odd. So right now, this one is saying down, up. Let's go see what they want. So this part right here is left, left is up, right, negative is down. So this currently is left side down, right side up, but they want left side up, right side down. So again, slap parentheses and a negative in front, and then that's your final answer. So in this assignment, I mean, we did this in the last, in the last chapter. It's just that now we have the i's that we have to work with. Always look for the shortcuts and do those first. And then We have two shortcuts we know. We know the difference of squares, and then we know the perfect square. And then just double check that end behavior. If the instructions off to the side here, if these right here say the opposite of what the current one is, you just put parentheses and add the negative. And if you don't put those parentheses, that makes your problem incorrect because now you're changing the zeros. So you should have enough information now to be able to do today's assignment.